A very good afternoon to everybody present here. It is an absolute pleasure to have all of you present with us today. So, Sage Sustainability, in our endeavors to bring sustainability to the forefront, we are starting a new webinar series, which is called Traverse. So, Sage Sustainability is the only certified B Corp advisory and consulting firm in India. And as an impact-oriented organization, it is our mission to see sustainability at the core of every organization on the planet. So our webinar, Traverse, aims to explore the boundless possibilities, ranging from social impact, environmental impact, all the way to innovation and entrepreneurship in the world of sustainability. So in our first session today, we'll be exploring green infrastructure. Now, according to the new climate economy, the world will need to invest about $90 trillion in sustainable infrastructure by 2030. That's within the next 9 years. The construction industry is responsible for 36% of all energy consumption and 40% of all the CO2 emissions. Therefore, now more than ever, we need a transformation in the construction and infrastructure sector. So today we will be exploring the topic in detail through an intellectual exchange between Mr. Tarun Jami, the founder of Green Jams, and Dr. Shashi, CEO of Sage Sustainability. Now, a little bit about Mr. Tarun. He's a founder of Green Jams. It's an innovative startup focusing on bioaggregate building material, which is agrocrete and hempcrete. He has an MSc in environmental science from Gujarat Forensic Science University and a PhD in civil engineering from RMIT University. He was also featured in Forbes' 30 Under 30 Asia. It is an immense pleasure to have you with us here today, sir. Thank you for taking your time. Now I request Dr. Shashi to take over.
Thank you, Tarun. Welcome, Tarun. We're absolutely privileged to start this series with you. Sustainable, as I said, I worked in the construction industry, and so it's a big ticket item when it comes to sustainability. So having you as a first speaker is an absolute privilege. So Tarun, just before we start, we'll just say that amongst our audience today, there'll be two kinds of people. One who may be familiar with sustainability, but not with construction. And the other may be familiar with construction, but not with sustainability. And maybe there are some who are not familiar with either, and you see that's their keenness to understand, sustainability in construction sector. So for the sake of those, I think we'll try to not use the jargons and try and explain today in as simply possible a manner as we can about the value proposition that your organization and you are bringing to the forefront. So the first question from my side on behalf of all our audiences, what is Green Jams? What is your product about?
So Green Jams is basically the name of a startup. I started this in 2017, essentially as a response to my own personal guilt, because I'm a civil engineer, and I mean pretty early on I realized that this is the same numbers as Tuhin basically mentioned, right? The contribution of construction to the destruction that there is. I know it's an oxymoron, but then when you look at it, I mean, as a civil engineer, as I was graduating, I was thinking, I mean, I'm going to be joining the workforce, and I would essentially become an enabler of all of this construction. What can I do to change it? So it was essentially Green Jams is basically a response to this particular question that I had back in 2013, 2014, and then by 2017. I did my own academic study. Then there was also a fair bit of commercial R&D. There was a huge amount of research involved. I studied so much that I actually became scientific authors on this particular topic called hempcrete, which I was looking to develop for the Indian construction industry. And yeah, I mean, as fate had it, I'm still actually the only guy who's an authority on hempcrete in India today, at least within the scientific community. But then again, I mean, this is where the beauty happens, right? Once like core science and R&D basically meets industry is where the real magic happens. And that's what I wanted to bring about. So in 2017, I started Green Jams with a singular goal of creating hempcrete for the construction industry without any background in business, without any background in entrepreneurship. Along the way, 2 years later, I realized that there's something called market and there's something called product market fit. And I quickly realized that hempcrete does not have it, but not because the product itself is bad, but because there were quite a few other back-end things that weren't working out. We don't have a hemp industry. We don't have a steady supply of raw materials. So while I've been able to overcome the technical issues, these things were still a problem. So in 2019 was when I happened across this the Delhi air quality issue. I was actually in Delhi late 2019. I personally suffered that issue. My car is now 15 years old, so it doesn't have any of that advanced gadgetry where you have air filters, cabin filters, and so on. So literally everything that was outside my car was going into my body. And I almost crashed my car because I couldn't see. Like the sort of, it gave me this very, very bad headache. And then I was like, man, I have to leave Delhi. And I literally post haste, I just left Delhi. And then I immediately started to feel better. And I'm like, how are people living for a quarter of a year, their entire lives in this kind of air quality? So that's basically when I did a little bit more study. I was very late to the party to realize that about 100 million tons of crop residues are burnt annually in India, which costs our country approximately 2 lakh crore rupees. It's not even 2 lakhs, it's not even 2 crores. It's a combination of about 2 lakh crore rupees because of loss of productivity and public health. And that's when I was like, man, this needs a problem. This problem needs a solution. Then I looked at then I got some crop residues. Then I started, using my own technical skills. And finally, we developed what we call Agrocrete now. That's our flagship product. So in a nutshell, we create carbon negative building materials that are not only cost effective, they're essentially reducing construction costs by almost 50%. And automatically, just by switching out regular bricks with Agrocrete, you're able to improve the energy efficiency by another 25%.
So Green Jams is about the solving the brick problem in the construction industry, which is one of the materials, which is one of the largest input, in fact, which also contributes to the carbon emissions, and along with a lot of cement related, emissions. So when I look at Green Jam, so what I see clearly is there are 3 products that you have trademarked. One is hempcrete, Agrocrete, and the binder. So I see it as a maybe 2-some package because agro and hemp are like optional, like one would use that. And in the construction, and maybe there's very young people who may not really have a clarity on how construction in India really happens, is that basically we're talking about wall material, right?
Yeah.
So there is this foundation in a building and there is this wall material and there is this roof. So basically we're providing the solution for the wall material.
Yeah.
Is that right? Yeah.
Correct. Yeah.
So when there are 2 things that are very significant in the product USP that I see. One is it's carbon negative, and the second is that the cost is can be 30% or 50% less. We will come to those attributes, and I see that as a too good to be true proposition, in the sense that on one side it is carbon negative and it is cost effective. Then I feel like we can just sit on our chairs, and I mean Tarun can supply to the whole of the world, and it can help reach net zero emission goal so quickly compared to otherwise whatever confusion is lingering on. And these are the kind of solutions, and this is in construction sector. We're looking at electric vehicles, and there are a lot of other interventions which are happening. So which for us is so positive that it looks like what we're what we are working on will see the light of the day, that in the end, the good sense will prevail and world will be a better place to live. Now, looking at that, I want to focus on your product bit by bit for every construction in the sense that we can first explore, I think for the audience also, we'll first explore on the environmental front and then maybe on the social side, how your product is meeting the requirement of the new world, sustainable world. So first, let's talk about energy and emissions, and then we can talk about the water and then about the waste. So in a very systematic manner. So from energy and emission standpoint, when you say negative, I first want you to kind of de-jargonize it again for the audience. When you say carbon negative, there are a lot of words used: climate neutral, carbon neutral, climate positive, carbon positive, and there is a lot of confusion that lingers on. So please clarify, when you say this brick is carbon negative, what do you really mean by that?
Cool. Yeah, I knew this was a follow-on question. So it's very simple, right? Whenever you're bringing in any product that for that matter is essentially a sum total of its raw materials. So you essentially bring in inputs from somewhere, and then so for example, if you're making let's just take the example of a paper boat. So essentially, when you want to make a paper boat, you're basically the first thing that you need is paper, and the second thing you need is manual labor. Right. So manual labor is basically it does not create any emissions. I mean, by virtue of us living, there is some sort of impact, of course. But then because of the manual labor, you're not really emitting any carbon dioxide into the atmosphere. So that process is basically carbon neutral. So once you start looking at the top to the end, like the beginning of the task to the finish of the task, when you look at where all you've actually put in inputs, or where all you've basically gotten in materials, and then if all of the sum total basically results in a null value or zero value, then it is called carbon neutral. And paper manufacturing itself, like you get paper is made of pulp, and then once you start looking at the whole process of paper, you basically extract the pulp from the trees, and then there's a whole amount of chemical process and everything, which essentially again consumes energy. So in each step of the paper manufacturing, there's always going to be some resultant. So wood again is basically a carbon negative material, and then that is where it begins, which essentially means that wood essentially, while it was growing, the tree was growing through the photosynthetic process. It was absorbing CO2 from the atmosphere and then becoming the organism, the body of the tree itself. So that is why trees are considered to be carbon negative. But then once we harvest it, once we remove all of those things that we require, eventually a huge amount of essentially carbon again goes back into the atmosphere through multiple processes. So in the end, it slowly starts reaching that carbon neutral stage, the pulp. And then obviously you also have those other line items in terms of the amount of chemicals that went in, the amount of heat that went in, the amount of electricity that went in, and all of those essentially have their own values. So that's basically it. Once you do the sum total of all of these line items, if it is a positive value, then it means that there is an X amount of carbon dioxide being added to the atmosphere. If that X equals to 0, then it is carbon neutral. If that X is equal to a negative value after you do the sum total of all the line items, then it means it is carbon negative, which essentially means we are the net effect on the atmosphere is that we are removing CO2 concentration from the air.
Basically, if we can sum it up, it is to say that some of the carbon which was lurking around there is now bound in this product. Would that be correct?
Absolutely.
To say? Okay.
Yeah.
All right.
Okay.
So,
I took 15 minutes. You took 10 seconds.
Those 15, not 15, maybe 1 minute was important. Yeah. So once we know this is a climate, when you say carbon neutral, so you also said this is across life cycle. It is not just, you're not just comparing it for the material versus material. You're talking about the life cycle emission. Is that again? Yeah. Okay. So now it comes to the next question is about the other factors, like you said, uh, the assumptions that we're making, which means I'm assuming these assumptions are there that the factory is close by to from where it is getting constructed. So there must be a lot of other assumptions, which must be emphasizing local production. Again, is
Yeah.
that understanding correct? So that there's not a lot of transport related emissions, etc. Okay,
Yeah.
sounds good. So in terms of energy, again, energy and emissions are so correlated. So for the benefit of everyone else, I think once we've understood emissions, we've also understood energy, and for how the trend is now and ought to be. There's a lot of movement towards renewable. Even in mainstream construction industry, you can see that people are looking to move towards renewables, for example. And supposing you were to add for whatever you require power, if you were to add that renewable component to it, would it be further carbon negative, if I may say?
Yeah. I mean, that component would, how do I put it? The negativity value, if it is this much, will become this much.
That's one. So again, you are not, once what you are valuing right now as carbon negative is not the full potential of it compared to the
It's not.
mainstream. It's not.
Yeah.
So it can be further carbon negative based on the construction industry, the construction, whosoever
The
partners.
manufacturing process.
Yeah, manufacturing process can also be. So there is always, to sum it up again, there is a material component, there is a process component. So material
Absolutely.
component is absolutely negative, and taking some assumptions, even the process component is negative, also leads to carbon negative. But now add on the renewable energy into processing, this product has far more potential than what Tarun is currently, I think, speaking
Yeah.
about. Right? Yeah.
Yeah.
Okay. So now come to the water. Considering we have only 1 hour and we have to cover a lot of ground, so I will move quickly. So anyone who has questions on this aspect can ask, and we can kind of talk about that alongside. But we'll continue. So on water, how does this construction sector is also very water intensive? We all know that. So how does this product fare on water footprint?
So at this current point, we are also slightly water intensive. Unfortunately, we haven't been able to overcome that issue, basically because of the nature of the raw materials itself. Okay. So a very important aspect about the manufacturing process is essentially the treatment of crop residues, which is very, very important because, so for example, if you're taking the case of paddy straw, it essentially comes with a shiny layer on top, which is called wax. If the wax is there, then it does not bind with anything. And that's one of the biggest problems that we had to solve, was basically removing that wax, because of for which we use a hot water treatment process. While the water that we generate is not highly polluting, it still contains a fair amount of wax and other extractives from the crop residues. It's not bad for the environment. In fact, it enriches the soil further. It's just that we either have to be disposing it off correctly. At this point, what we do is we dispose all of that water into the field, and then we've noticed a marked difference in how the crop residues, how the subsequent crops also grow quicker or become more healthy. But what we essentially want to do is make sure that we're recycling all of that water by removing all those organic compounds that are there in the in the wastewater. I mean, I don't like to call it a wastewater, because in the end, it is essentially carrying nutrients that are great for agriculture. But yeah, rejected water.
But you are saying that if there's a layer of filtration that kind of meets your requirement, then it is all good. Whatever water is you are using for the manufacturing can be actually reused.
Yeah, we can close the cycle, we can close the loop. It will come back into the
cycle without much without adding much cost for the filtration. That's what you are saying.
Yeah.
Okay. And the third we would come to is the and you're also saying, sorry, on the water, that 1A quantity there is maybe equivalent to the regular construction sector, but in terms of quality, there is not so much of a problem, but then it can be solved. The problem can be solved if we can close the loop everywhere. The third important issue we'll talk about is waste. And you already started your conversation with the Delhi, that it's hemp. And you made a very big point there that hemp, what you were thinking about hemp initially and when you started, was a material you would want to grow. And this is the material that people want to actually kind of just burn, right? Like it's an absolute waste. In fact, it's a big nuisance for the entire region, right? So, and it doesn't, I think my colleague probably mentioned to me that in Singapore, even in Singapore, that kind of air quality deteriorates when in the neighboring areas, they do the similar thing. So that problem is not inherent only to our country.
No,
there
it's not.
are many places in the world where there are similar practices, and then there are similar health hazards, as you said. So now we're talking about a waste, and that's where the whole, I think, the game begins. That it's not like you need additional area for something to grow on. It is actually making use of, and that again staples. It's not like a fancy some crop. You're talking about paddy or wheat, in that sense. So large. What did you say about 100 million tons? You said
in India, that is. It's about 100 million tons. But if we were to essentially account for all the fugitive fires, right? Fugitive open field burning and all of those combined across the globe, we're talking about somewhere in the range of 2 billion tons of crop residues being burnt.
Wow, 2 billion tons. Like that's like a phenomenal number.
So if we basically were to just take all of those 2 billion tons of crop residues and make agrofeed out of it, we're talking about approximately 3 billion tons of CO2 alone getting captured through agrofeed. That's like 10% of our, a little less than 10% of our global emissions. Carbon emissions. Yeah.
About 40 gigatons. We are at 40 gigatons.
38 point something, right? Yeah.
Yeah, I'm always moving ahead because I'm always thinking that there is more which is not being accounted for. Yeah.
Oh yeah, so, that's always there.
Yeah, and so now so the waste, number one, that your raw material is what your raw material is actually the waste that people have not really found. How when you approach the farmers saying that you have this product, and so what has been their reaction on this?
Farmers honestly don't really care what the product is as long as you are solving the problem for them. So I don't actually tell them what I'm making. I just tell them that this is how much straw I want, please give it to me. Okay. And they're more than happy to get rid of it because one, they're getting paid for it. So the labors are, the manual labor that they put in, or even mechanized, the inputs that they put in essentially get covered. So literally their harvest crop, so once there is a fair amount of labor involved, right, in harvesting the crop. So when we go in, we're essentially paying them for the harvest. So literally their labor becomes free. They're earning a little extra. So the inputs that they put in to get the final crop itself, the final product in their hands, essentially becomes free for them, or actually profitable. So the farmers are actually pretty happy. I mean, they don't really care what I'm making out of it. I just go tell them. And there's also a price for this. There's a fixed rate. We pay them 3,000 rupees an acre for the straws. And we collect approximately 2.5 to 3 tons of straw per acre.
2.5 to 3 tons of straw per acre. So it is a straight deal with the farmer that we pay you money and you allow us to, or they get you. You don't get into the labor, or basically they'll get you the raw material.
Yeah, they just get us the straw, and then I mean they've collected and put it in a field. It's our responsibility to just load it onto the tractor, truck, or whatever, and then bring it to our site.
And basically they were also burning because they didn't want to pay the labor, the money to kind of take the straw. That's why they were burning, right, in the first place, because they didn't want to invest in the labor to get the straw out.
Exactly. Yeah.
Yeah. So in terms of waste, okay, one, so what I can understand is in this brick, again, for those who are not familiar with the construction industry, construction materials, this makes one component, what else goes into the concoction that makes this carbon negative brick?
Yeah. So, I mean, all of our products, save for binder, are sorry, no, carbon negative I've already spoken about, right? All of our products are basically 100% upcycled. We essentially use the basically waste from a variety of sources. The agrocrete, again, I mean, it's a waste from agriculture. Then we use ash, which comes from any boiler process. Preferably, we use fly ash from the thermal power plants because that's a much larger problem to solve. And fly ash bricks are not attractive enough for the industry. And then we basically then the binding material.
Why do you say that? Like fly ash bricks are not attractive for the industry? Like if you can please elaborate. I don't understand that.
So we've seen this that in a lot of cases, in a lot of these, even basically private industries, right? NTPC has a pretty robust method of utilization of fly ash, but then a lot of these other industries where they have captive thermal power plants or some other boiler process, they find it extremely difficult to get rid of the ash because whoever comes in to actually produce the bricks out of, they find it very difficult to market it. And we've seen that it's not very attractive, right, in terms of how it looks. It's a little gray.
I wanted to say it's like a smoky gray color, which kind of, it looks like it's made of some mud or some smoky thing. And then there is this rejection of that material, aesthetically speaking, right?
Yeah. Aesthetically also, it's not very good. I mean, see, mud is also fine. Like CSEB is all the rage right now in Bangalore. And people are loving that product. And I'm very happy about it, even though it's a competitor. But jokes apart, basically, it's essentially the appearance of the block itself is not very attractive. I mean, people take one look at it and I'm like, I'm not really sure I want this. It's sort of like blackish almost. It actually looks like it is made using waste material. And normally people do not want to
build their homes with, or their,
which is actually considered waste. Like you automatically when you tag it as waste, I mean, it becomes very unattractive. So that was also something that we had to work on, right? From in our business point of view, we wanted to build that brand name of agrocrete. We didn't want it to call it a waste material. That's why we call it carbon negative. We call it agrocrete. Even though we essentially get all of our raw materials from industrial waste streams, we've very consciously made a point to make sure that we're not waste to wealth. We're basically value driven. It's just that our raw materials come from here, but once you feel the product, once you touch the product, you would realize that this is more than what meets the eye.
Great. So air also, we already, amongst the environmental dimension, we've already touched upon the air because, the only,
I'll just sum up the air bit a little bit. So our process does not have any furnaces. We don't use any kilns, none of that. I mean, so that's basically after the blocks are produced, once the press and everything is done, once you bring it out, we don't even water it because everything that the block needs to complete the reaction and become strong is already there in it. So all that we do is we just bring it out and put it outside for the cure to take place by itself. Yeah. So the air is also now cleared.
Air is also not. So I also saw a video on your website where you were interviewing the masons who were building that, the first building, I think what you mentioned. And they were saying, I think the question was being asked that how many days, we'll come to those points in the social dimension, but just again, the point of cement, because I think that's where I want to emphasize to those who from the construction sector, that you were mentioning kitna katta laga usme. So first of all, maybe if you demystify bags, right? Like that's, so they said something like in the other building, it takes
20 bags.
20 bags and here 12, right? Is that right?
8.
Okay, yeah, sorry. So 20 versus 8 in terms of that cementing material that you're talking about.
Yeah. So basically, when you're making any wall between two bricks or blocks, there's a mortar layer. So to create the mortar, it's the most widely used material is cement. So that's basically what we asked them. I mean, if this were made using red brick, how many bags? And they were like 20, which is equivalent to 1 ton of cement, versus ours where it was only 8 bags, which is equivalent to about 400 kg. So that's straight up 60% reduction.
It's further so now I come back to, I want to understand this much better. So when you're talking about carbon negative, you're talking about the product, but
Yeah.
I'm also talking about the carbon negativity of the entire construction that is done using. So there is also factored in less cement, and cement is hugely GHG, right? Like we always read cement as GHG. So whatever reduces cement use is further making it carbon negative, right?
Yeah.
In the construction. So that's fantastic. Is there any VOCs related, and even in the manufacturing of, there can be some in the binder, right, at this stage?
No, even in binder, there's actually no VOC. So binders are basically mineral materials that essentially get created when you're producing steel, stainless steel, any ferroalloys. There are quite a few mineral materials that get created. So what we do is we just take them and create binder out of it.
So this is also a VOC free product.
Yeah. So some amount of VOC is possible when we're treating the straw with the hot water, right? So some amount there is some vapor that gets created. So at that stage, a small amount of the VOC gets generated. But again, how much VOC gets generated from crop residues anyway?
Yeah. And what it is still binding. So these kind of questions people may have in their mind to kind of dismiss it, that it can't be so good. So I'm exploring each one of these questions systematically. Now we come to I think we've covered the environmental dimension. We'll come to one thing I think we've missed out on is the soil, the top soil in the conventional. The one additional benefit is that the topsoil in your product is not getting removed at all as compared to the red brick that conventionally is used. So again,
red brick and CSEB both require topsoil.
Yeah. So in that sense, it is in fact addressing all the strands of environment that possibly we are wanting to address, right? Okay, we'll come to the social side, Tarun, now. Number one, you already talked about, we've already covered some of the ground in terms of that they have additional income to say remove the straw, which otherwise, and so the air pollution also is going down, which also has health benefits. So it is benefiting health for even those who are not like, for example, farmers, yes, but it impacts, like Delhi is not a farmland, but it's all around, only the air kind of gets accumulated in a certain manner at that point of time in September, October or so. So the nuisance of air pollution is gone, additional income. So there are two of these very, very clear. The third, which is most important, which is your USP also along with carbon negative, is that it is cost effective. So let's discuss that. So when you say the costs can be cut to 50%, or I have already also read 30% at some place. So whatever, whether it can be arranged 30 to 50%, what is it attributed to? Is it just that the cost of this product is less, or also because of the cost of the cement is less for construction?
Yeah.
Could you
elaborate? That's basically it. So here's one negative. Perceive the negative which is coming up about the product. So when you compare say regular red bricks with agrocrete is slightly more expensive, but product to product comparison. But where you essentially save the most amount of money is in terms of the amount of material required. So basically cement, the amount of cement required to do the mortar jointing, the amount of cement required to do the plastering. Because of a much cleaner finish, the amount of plaster required also reduces significantly. A mason who's actually very used to putting thick layers of plaster also cannot help but make a thinner layer of plaster because he doesn't actually need to put so much. And this was something that we have seen with our own eyes. And then, but the biggest, however, impact comes in terms of the lesser amount of time required, which automatically means that masons or all of the workers who are working on the particular project would be working for a lesser amount of time. So automatically the man days reduce and the associated cost also reduces. So it is through these factors we're actually able to reduce cost of construction by 50%.
So if I may say, the other construction materials, if I can say, other construction materials are reduced and the cost of labor is reduced. Therefore, the cost of the construction goes down. And this is a win-win solution for the customer. And do customers recognize that readily? Of course, from your queries, you can see that. I'm sure you'll be able to judge that they do recognize that. Do they kind of haggle for the cost for agri brick versus agrocrete versus, like, do they say it's cheaper, the other is cheaper?
Oh, they always do. I mean, it's difficult to understand these complex calculations, right? I mean, everyone wants to see. So here's this very funny incident that happened after the Bessetti article came out. The second day, this guy from Haryana, he called up, and he's like, "Bhai, मेरा petrol pump है, मेरे को यहाँ पे बाउंड्री वॉल करना है और मेरे यहाँ पे 3 रुपए की ईंट मिलती है, तुम बताओ कितने में दोगे?" And I'm like, कच्ची है या पक्की है? 3 रुपए में कौन ईंट दे रहा है भाई? So these, I mean, I also get these kind of calls. I mean, they essentially want that, you know, if they're basically getting a brick at 3 rupees, they want me to give it at 1.5 rupees. Exactly. So that's the sort of expectations that people come with. And it's part of business, no? I mean, you always get these kind of queries. And it's also part of my job to educate these customers and let them know that, hey, this is not the case. You would be spending slightly more on agrocrete than you would say just material to material number of bricks sort of comparison. But then when you do the whole net calculation, it's going to be much cheaper. So we have an analysis sheet which clearly shows 1600 on the bottom line, 850 on the bottom line of agrocrete and red brick, and they're like, "Okay, makes sense."
Okay. So, I mean, there is a lot of education that needs to be done, considering you are dealing directly with people who need small quantities. Like, it's a lot of customer queries also you're getting at this stage, right?
Yeah.
But you won't see that challenge if larger industry is taking this up, you know, and because it will be kind of factored in and they can understand that more readily and easily. Yeah.
Yeah. No, even with larger industries, we face this issue. There is always education that needs to be done. Like we're actually speaking to quite a few large developers at this point, and we always have. I mean, we've had like almost 4 rounds of discussion only on the costing. Me answering their queries, getting their rates, factoring it into our own model, and then still showing that, hey, it's still cheaper. Go for it.
Okay, so now I just want to, this was the construction side of it. Now we have, you know, taken your bricks, made our home, and we are living in it. That is the other side of the open. Tuhin initially said 40% in the, and also it is during the entire life cycle of the building that emissions, you know, are attributed to the construction and built environment, if I may say more appropriately. So how does this product fare in terms of use phase of the product? We've made peace with the fact that we're very happy that you know, we carbon negative. Now I'm living in that home. How do you think, does it increase my energy consumption, or does it reduces my energy consumption? How do I feel aesthetically? How will I feel inside the home? What are the attributes of the product in terms of humidity? What will humidity do to the product? What will extreme heat do to the product? We would want to understand that aspects.
Sure. So basically, by worst case scenario, right? I mean, we're always conservative whenever we are doing any of our projections and calculations. Without the intervention of architectural design, or without essentially changing the appliances, without doing anything, just by switching out. So these are some simulations that we actually carried out. Just by switching out a regular brick wall with agrofeed, essentially reduces your energy consumption by 25%. Straight up. That is guaranteed. That is the minimum that is going to occur. So
even if architecturally misdesigned place.
Yeah, basically the same architectural design, nothing changes. Only the walls basically get changed, and you automatically see an EPI reduction of 25%. So that's literally, yeah, 25% is huge. I mean, if you have if you were getting monthly bills of 10,000 rupees, now it's gone down to 7,500. That and multiply it by your lifetime of the building, and then you automatically have huge huge savings. But then most importantly for us, when we were looking at, we had to make a conscious choice in figuring out how it plays with humidity, right? So when you're talking about crop residues, they're hygroscopic in nature. I'm sorry, I'm using a little bit of jargon, but what it really means
is water.
So what it means is it interacts with moisture, and everyone knows it. Like, you take some straw, you put in water, it's going to absorb all of it. And so we had to make a conscious choice in figuring out if we want to retain that property or forego that property. After talking to the industry for almost 2.5-3 years, giving people certain options and then getting customer feedback, we realized that people understand very little about humidity. People understand very little about moisture. At this current stage, it is important for us to forego the hygroscopic property of straw and make sure that the humidity and all of that is very, very less. So our blocks essentially have a water absorption of only 10%, and that is way lesser than red brick or any other competing material, save for a few. So that was a conscious choice that we made. And second, we were like, thermally, it is very insulating. Let's just not play with humidity at the moment. Once we essentially create specialized variations of agrofeed is when we will also make it hygrothermal, or hygroscopic.
And if it's extreme, so the new report, IPCC report, has come, and in no uncertain terms, the report uses the word unequivocal evidence for the climate changes right there happening. And keeping that in mind, many cities in India would face extreme heat. Roorkee, where you are, and Delhi, Gurgaon, and many central Indian cities, even rural areas, everywhere. We can see Rajasthan. We can see temperatures touching up 48, 49 on many days. This is what they say. So how does it fare in extreme dry environment again? Does it help protect? Have you done some work on that?
That's basically it, right? So we were like, let's not make it hygroscopic. So let's just, make sure that it's retained its own thermal insulation property. So we tested it in some really rigorous conditions. 24. So we have done like cyclic wetting and drying, in which what we do is we subject the blocks to 24 hours of wetness. We literally dip them in water for 24 hours, and then the next 24 hours we essentially keep it in an oven at 510 degrees centigrade, and then rapidly evaporate the moisture from the block, basically to simulate some really, really harsh conditions to check how it is going to perform in both scenarios. And the IPCC report also basically mentions two things: heavy precipitation and higher amount of extreme drought conditions. So we had to understand how this is going to perform. See, with the case of red bricks, it does not have any of those problems. But if you were to look at AAC blocks, the same cyclic wetting and drying scenarios, almost 8 out of 10 blocks will always develop cracks. They literally split open. So for us, it was very important to essentially understand if this is a scenario or not. So yeah, we've done all of those testing. Durability is super important. I know, I mean, going in the future, no one's going to be living in apartments for more than 50 years. There's always going to be demolition. But we were like, we'll assume that, people are going to be living in in these homes for at least a century, and then design the material accordingly.
Correct. And also the fact that, like you said, that because they're so well insulated, and the feeling of heat inside, even at that temperature, would be far less compared to the conventional.
Yeah.
Yeah. So now maybe I think if we can just talk about the qualities of hemp versus quality of agricrete. Like agricrete versus hemp. Is there any plus point in the hemp?
So for sure, yes. The only advantage that hempcrete has over agrocrete is that hempcrete is more thermally insulating, better suited to harsher climates, colder climates, basically. But if IPCC report is any indication, that those climatic zones are only shrinking now. So I mean, yeah.
But also there is a quality of fire retardant. How do you say that? Fire retardant.
So fire resistance is not a property of any of these crop residues. Like even hemp basically catches fire. Like if you take hemp and if you take crop residues, both of them would essentially catch fire at the same rate. In fact, hemp is more flammable than paddy straw.
It's so strange. I think I saw a documentary where they were highlighting this quality of,
that is basically a quality of the mix. That is the most important thing. So if you take, if the binders are good, then it becomes fire resistant.
It's not an inherent intrinsic quality of the material that it wants, because it was so strange to hear that. But then we didn't really understand. Thanks for clarifying that. So in terms of aesthetics also, is hemp and agri, how different do they look really in terms of their look, feel? Is it like hemp? How would you, if somebody asking you, you decide for me whether I should choose, money is not a problem, hemp or agri, what would you tell them?
Oh, in terms, so I mean, immediately, if that was the case, then I would always recommend agrocrete to hempcrete, because agrocrete is solving a much bigger problem than hempcrete ever can, or ever would, even in the future. I mean, people look at hemp as this miracle plant, as this savior of the world, and all of that, but that's not the case. I mean, people need to be looking at it objectively. Right? People say that we'll basically produce huge areas of hemp and then create paper out of it. And not this is basically where things get very funny, because not a lot of people pay attention to science, right? I mean, just because something is possible does not mean that it is always the right thing to do.
So the practical or the most feasible or the relevant thing to do. Yeah.
Yeah. So, and there was this one life cycle analysis study. Unfortunately, there aren't many. Because objective scientific researchers are very few, and Google researchers are many more. So there's this one very good quality scientific publication, peer reviewed, which essentially compared paper made out of hemp and paper made out of regular wood, and in the end they concluded that the environmental impact of paper made using hemp is much higher than the paper made using wood pulp. And this is a very unpopular opinion, right? And that's basically why the paper never got popular, because everyone started, I mean, we're trying to punch holes in it. But I know for a fact that 2 or 3 decades later, that paper is going to get cited way more than any other scientific publication related to paper, that is, of course.
Absolutely. And also yeah, please. Yeah, Tarun, sorry.
So the point that I was trying to make is, people always succumb to propaganda, right? The downfall of hemp was also because of propaganda. DuPont, patented nylon, and then Harry, whatever his name, he basically then lobbied for the banning of cannabis. There was a fair amount of racial,
absolutely, yeah.
There was a fair amount of racial injustice and all of those things that factored into cannabis getting banned. And now again, cannabis has got like,
and it got banned in India also. It got banned in India also. Yeah.
India, because we're signatories to the UN, and then literally UN. We all know that UN is essentially a puppet of the US. And back then, when the UN got created, it was a puppet of the US. So there was a lot of pressure on us, on indigenous communities, on regional communities. In fact, we were one of those only countries. We were one of those very few countries. Basically, the entire third world was opposing the single convention on cannabis on drugs, basically. But then again, it's basically all propaganda, right? No one really, not a lot of people look at things from a scientific standpoint, and that is the reason why a lot of innovations do not see the light of day. That's also one of the reasons why half-baked innovations see the light of day. Like, for example, Adidas creating t-shirts out of plastic. I'm like, congratulations, you've literally made this plastic worthless now. Like, I'm going to wear the t-shirt for a while, and then what am I going to do with the t-shirt? Throw it
back to the
and I can't even extract that yarn back out of the t-shirt and then make more, because they've already ruined that plastic. Rather make some more useful, sturdier products out of that plastic, instead of just
we always discussing this till everybody knows the loop to close in almost everything else, and then the additional problem of blending two materials. Basically, we were also saying that between the PET bottle recycle, and if it is pure, that is different. But if it is mixed with 30% organic cotton, for example, then segregating that again becomes a problem. So that's really one of the issues. So now I think maybe we only 5-7 minutes left. So maybe we can ask anyone to whatever questions you have, please.
Hi, Manju here.
Yes, Manju.
So this is regarding the scaling of green jams. Now, provided you have all the support that is required to scale up the business, what is the kind of goal or target that you think you will be able to reach maybe by 2030?
Oh, so for us, it's all about billion-ton scale of carbon removal. That's basically is the overarching goal, and that's always something that we would be looking at. I'm actually sitting right here, and I've set some supremely ambitious goals, which are that we want to essentially remove 10% of anthropogenic carbon emissions. Actually, capture 10% of anthropogenic carbon emissions. If we even hope to, keep the average increase in temperature up to just 1 degree centigrade, then I think we would have a major role to play in it, and that is basically our target. It becoming a multi-trillion-dollar business is a secondary thing, of course. That is just. I think the size of a check is always going to be the size is always going to be proportionate to the size of the problem you solve. So if we remove 10% of global anthropogenic carbon emissions, I'm sure the check size is also going to be proportionately large.
So by 2030, you aim to have a substantial contribution made to the net climate neutrality or carbon neutrality for many organizations, right?
Yeah, by 2030, at least we would have reached 1 billion tons of CO2 capture. That's the goal.
So wow, that's 1 billion ton off through this product. I think that's absolutely a win-win for the construction industry. Anyone else? Any question for Tarun?
Yeah, hi. So how would you compare the strength and durability of agrocrete versus hempcrete?
Versus hempcrete. Hempcrete is much weaker than agrocrete. Also, hempcrete has a few issues with durability. It all essentially comes down to the sort of binder that you're using. The sort of hempcrete that we make is fairly durable. I mean, as durable as what agrocrete is. But in terms of strength, it essentially suffers.
Okay. And Tarun, how many, one question I quickly have is how many kind of jobs in the factories that you're manufacturing units that you think per whatever measure you'll be able to create? Since that's a very, very big measure of our SDGs, right? Creating livelihood.
Yeah.
Yeah.
Yeah. So if we basically set up 1,000 manufacturing units, we have created opportunities for 12,000 people.
How many?
12,000.
12,000. Okay. All right.
And we would need significantly more than 1,000 manufacturing units across the country.
1,000 manufacturing units.
Yeah.
And you are already approached by about 500 to 1,000 people for manufacturing, or they were your they were for customer queries?
There were customer inquiries. They've received almost 200 inquiries for setting up manufacturing units.
All right. Okay. So what really is the barrier now for you to scale, if you can kind of sum that up?
So the barrier right now is essentially the production, the manufacturing. That's essentially the barrier. And when we talk about production, then it automatically also brings the question of capital expenditure. Finance is a major barrier at this point. It's just that, once we get that momentum going, I'm very confident that finance also will solve itself.
All right. Okay. Anyone else? Any questions? I think we'll wind up. It's already 2 o'clock.
Yeah.
If there are no further questions, what is your message to all of us? I won't even say young people, to everyone. I think everybody's contributing to carbon. So young, old, everyone. What's your message?
I think honestly, I mean, I would just basically ask everyone to look at themselves as human capital and be conscious about the sort of capital you're contributing to your own cause. Like, for example, if you're working for Pepsi or Coca-Cola, and the major business is essentially creating the plastic bottles and not the water, then you're responsible, you're enabling Coca-Cola or Pepsi in producing that many number of plastic bottles or plastic pollution. So just be conscious about the sort of companies you work for, because you yourself are a human capital. So it's important to choose your cause wisely.
All right. Thank you so much. I think we are very, very excited. We were very excited to hear about Green Jams and your product, anything which is carbon negative sounds music to our ears at our consulting firm. And we are always looking at, what is it that we can also introduce to our, clients and create awareness further on these solutions and inspire so many through your work. A lot of people will get inspired to create solutions. I'm sure about that. So
I don't know about that.
We wish you a great future, and I hope you're able to achieve your goal and go much beyond that. So thank you so much. If there are no other questions, thank you very much, Tarun. Thank you.
Thank you, Shashi.
Thank you to all the participants being there. We had some more, I think. Some people left in between. I'm sure there are competing engagements. I got some regrets saying they have some other competing engagements they have. But we will put it on the social media so that people can watch later. I have requests for that, and we will facilitate. Yeah.
Cool.
All right.
No problem.
Thank you. Thank you, Tarun.
Thank you, Doc. Thank you so much.
Bye.
Bye-bye.
Thank you, everybody, for joining.
Thank you, ma'am.
Thank you, Manju. Thank you, team. I think we have we had some people join, and some people were saying that they weren't able to join the call. I think Ram was saying he wasn't able to join the call. So we'll have to check if there were some people who didn't really get to.
Yes.
All right. Thank you,
Okay.
team. Bye. Yeah.
Bye-bye.